In this video, what I'd like to do is let's do steps 10 and 11. Let's answer the questions, and then let's find the tangent line, the slope of the tangent line on the position graph, and compare that to the velocity that we already calculated. Okay. So answer these questions, right? Question number one, is it the shape you predicted? So go back to the picture you drew. Did you draw a straight line? Did you draw a curved line? And if it was curved, was it curved in the right way? Did you make it concave upward like that? I just don't know, right? So just talk about that, right? And then talk about the slope, right? What's happening to the slope? There's a slope here, there's a slope there, there's a slope there. What's happening to it? Is it getting bigger? Is it getting smaller, right? And then remember, the slope is the velocity, right? So whatever's happening on this graph to the slope is happening to the velocity of the object. Does that make sense? Is what's happening to the slope the same thing that's happening to the velocity as that little glider goes down the plane? That's what we're getting at there. Okay. Now let's get to the slope of the tangent line here. Okay. What we want to do is we want to look at the coordinates. See this tangent line? It's got a lower left point right here, right there, right? And it's got an upper right point right there. And we're going to use those coordinates to find the slope of the line. We're just going to use the point form of the slope of a line, right? Which is what, y2 minus y1 over x2 minus x1, rise over run, okay? But we got to read the graph accurately, and that's why we put all these grid lines on there. That's why we drew this thing to make sure it went across the entire axis and all that stuff, right? Okay, we got to go through the plot frame, okay? So let's read these coordinates here. This part right there, how far over and how far up is that? Well, I think looks like these are all tenths of a second. So that looks like it's 1.9 over, and since it's the x-axis, it's 0 up. Okay, so let's type that in here. I think our x is 1.9, and then this guy is 0.0. And you can just write it down to a tenth. I think we can easily read the tenths place, right? So I just said that point right there, okay, right there, is 1.9 over 0 up. Now let's read this point here. That point right there is 6 over, and how far up? This is, how far up is like higher math, right? So it's 0.05s, right? So 1.05, 1.1, almost 1.15. So I'm going to say 1.14 because I want to be different. Okay, so this guy is 6 over. I think we can say that. Whoops, what just happened there? All right, and then this guy is 1.14 up. Okay, really these have units of seconds and meters, but sometimes you can use units too much. All right, so again, we just read these endpoints. Now we're ready to find the slope. So put your values in here. And this gets a little tricky. So that top one, it looks like I'm doing both, but I'm not. 1.14 minus, and then y2 is 0. All right, so you go y2 minus y1 over x2 minus x1. So x2 is 6.0, and then this guy's 1.9. Okay, so again, it's y2 minus y1. This is x1 and y1, x2 and y2, right? Okay. Okay, so do I have that right? I do. 6 minus 1. Okay, so now we're going to put that in the calculator, and you have to use parentheses, right? You have to go the numerator we don't need to, but so 1.14 minus 0, right parenthesis, divided by left parenthesis, 6 minus 1.9, right parenthesis, enter. And I get 0.278. Okay, so just maybe round it to 3 sig figs. We really don't have that probably, but. And then these are meters per second. Don't know why that's parentheses, right? So remember that the numerator is meters, the denominator is seconds, right? Okay. Now we got to figure out where it is tangent, what time it's tangent at. And that's where this little vertical line helps us, because I put that right in the middle there. So if you go all the way down here to the axis, that point right there, where it intersects the x-axis, that's 4.1 seconds. It's a little bit beyond that. It's like 4.105. I don't even know. I'm just going to say 4.1. 4.1 seconds. All right, and now we're going to compare the slope, this slope that we got here, the 0.278, to the value of the, to that value, right? We're going to look up the value in the table, right? So what we're saying is that in that table where we calculated the velocity using the instantaneous velocity formula in the spreadsheet, at 4.1 seconds, we think it's going to be around 0.278. Let's see what it really is, okay? To go up here, and we're looking for 4.1 seconds. Well, there's 4.1 seconds, right? Notice that it's 0.273 and it's 0.285. So I'm going to write a sentence like this. The slope of my tangent line was 0.278 meters per second. The values of the velocity at that point in meters per second at 4.1 seconds ranged from 0.273 to 0.285. This is a remarkable concordance. It is amazingly close. I don't know, it's in the ballpark, right? Okay, so again, find that time. Okay, the time is 4.1 seconds, and I got that from this point right there. Okay, 4.1 seconds, we think the slope is 0.278. So let's look in the table. Right, where's 4.1 seconds? There it is. Right, and you're not going to get it even. It's not going to be exactly, so you'll have to compare it to a range. 0.278 looks like it fits in perfectly. So write a sentence. I mean, and you remember in your sentence, you need to say what your slope was and then what those values were in the table at that time. Okay? Is there anything else? Let me look and make sure. No, I think that's it. I think we've done steps 10 and 11.